Hello everyone, welcome to another Statistics 1 session for grade 13. So we are going to continue with the topic of representation of data, and in this lesson we are going to learn how to draw a cumulative frequency curve. Secondly, we are going to learn how to find the quartiles, the median and the percentile from a given cumulative frequency curve. And lastly, we are going to learn how to draw a box and whisker diagram from a CF curve. Right? So we begin with cumulative frequency curve. Example, the height of 30 plants are given in the table below. So this is what we call a grouped frequency distribution table, because the information has been grouped into classes, into intervals. Okay, in the first row we have height of plants, right? In the first interval is from 3 to 6 centimeters, the second interval from 6 to 9, the third interval from 9 to 12, and so on, up till the last interval from 18 to 21 centimeters, right? And for each interval we are given their corresponding frequencies, meaning the number of plants for each particular interval. Okay, so now to be able to draw a CF curve, a cumulative frequency curve, or an ogive, it's the same thing as CF curve, right? We need to develop a CF table, a cumulative frequency table. Now the CF table it only uses the boundaries. It does not use the intervals, right? So how are we going to develop this table? We start with the lower class boundary of the first interval. The lower class boundary is 3. So we start with 3 for the height of plants. Then all remaining values in the table, we are going to select the upper class boundaries, right? So 6 is the first upper class boundary, right? The next value that comes after the 3 is the upper class boundary is 6. Then we continue like this with the upper class boundary. We choose only the upper class boundaries, right? 18, we include 18, and lastly 21, right? This is the first step. Now we have to fill in the CF values, the cumulative frequency values. To be able to fill in the CF values, C dot frequency here means cumulative frequency. Cumulative frequency is what we call the running total, meaning we have to add the frequencies as we go through the table, right? How do we obtain the CF values, the cumulative frequency values? You have to interpret the table very carefully. So we have started with the lower class boundary. It is here. The height here is a height less than 3. So we need the number of plants whose height is less than 3. How many plants have a height less than 3? Let us see in the first table, do we have plants which have a height less than 3? No, we don't have any plants. whose height is less than 3. So the first CF is 0. Right? Now the second value is 6. 6 was the upper class boundary. So we stop at the upper class boundary. Right? Here we have less than 6 or equal to 6. How many plants have a height less than or equal to 6? Let us see. The boundary for 6, it stops here. How many plants have a height less than 6 or equal to 6? How many plants? Only one plant. Right? Next come the value 9. This is less than 9 or equal to 9. And since it was the upper class boundary, here it is. So this is the limit for the upper class boundary of 9. How many plants have a height less than 9? It's 2 plants plus 1 plant, meaning a total of 3 plants. You see, we are adding the frequencies. This is what we call running total. And here we have the value 12 less than 12 or equal to 12. It was here in the first table, so our limit is here. How many plants have a height less than 12 or equal to 12? It's 11 plus 2 plus 1, meaning 14 plants. Right? We carry on like this. Here we have 15. Here it is. So the limit is here for upper class boundary of 15. Still, we ask the same question. How many plants have a height less or equal to 15? So this is the limit for 15 less or equal to 15, meaning 10 plants plus 11 plants plus 2 plants plus 1 plant, meaning 24 plants in all. Right? Similarly, we carry on. Here we have 18. 18 is here in the first table, so this is the limit. To obtain this CF, we have to add 5 with the previous frequencies. Right? So 5 plus the previous ones was 24. So 5 plus 24, 29. And the last one, 21. It is here in the table. So the limit ends here. How many plants have a height less than 21 or equal to 21? It's 1 plus the previous ones, meaning 1 plus 29, it gives 30. Now at this particular point, you must check whether your cumulative frequencies, they are correct or not. How do you check? By simply observing the last value. The last value must correspond to the total number of plants in the question. Right? What is the total number of plants in the question? It was 30 plants. Right? So it is correct. Right? So after having developed the CF table, now we have to write down the coordinates of the points. to be able to plot them and draw the CF curve, right? So I have drawn the CF table again for you. We have the height, then we have obtained the cumulative frequency. Now we write down it in terms of coordinates. The height will be on the horizontal axis. This is the axis for height in centimeters, of course. And the vertical axis will denote cumulative frequency. Okay? Now think of this. The height is on the horizontal axis. You think of it as simply the x coordinate. The cumulative frequency on the vertical axis, we take it to be the y coordinate. So any point on this graph will be denoted by x, y, meaning height, the value of the height, followed by the value of cumulative frequency. So the first point will be x. X is free here, so it is free, comma y. Y is 0, so free, comma 0. The second point, 6, 1. The third point, 9, 3. The fourth point, 12, 14. The next point, 15, 24. The next one, 18, 29. And the next one, 21, 30. Right? Now we are in a situation in which we can easily plot the points to be able to obtain the CF curve. So we choose a scale for both axes. On the horizontal axis, I will choose 2 centimeters. 2 centimeters to represent 5. Right? So I start with 0 here, then 5, again 2 centimeters, 10, 15, 20, last one is 25. And on the vertical axis, I use 1 square or 1 centimeter to represent 5. This is 5, 10, 15, 20, 25, 30, right? 35. Now all we have to do now is to plot the points. The first point is 3, 0, 3, 0. So this is 5, 4, 3, 0. It's here. Next point, 6, 1, 6, 1. The next point, 9, 3, 9, 3. The next point, 12, 14. The next point, 15, 24. 15, 24. The next point, 18, 29. Here it is, and the last point 21 comma 30. Right? All we have to do is to join the points by a smooth curve. So here we are with the CF curve. We have joined all the points by a smooth curve, right? Whenever you draw a CF curve, it has to be an S shape, right? It has to be like this, S. Okay? So now, from the CF curve, how can we find the quartiles? The lower quartile, upper quartile, the median, and the interquartile range. Let us see. Here, the number of plants is 30, and 30 is an even number. The total is even here. So, the median is Q2. Let me write it, median. The symbol is Q2, and it is given by the 50% of the distribution, meaning half of the total, half of 30th, it is the 15th value. Note that the formula for median does not give you the median directly. It gives you what we call the rank. Then from the rank you have to locate it on your CF curve. So this is a rank of 15. A rank of 15 on the CF axis. It's here. So from here we draw a horizontal line till we reach the curve, and from there on we go down. Right? Right, so the value for the median is 12.5, and since we are dealing with height of plants, it's 12.5 centimeters. Similarly, we can find the lower quartile. The lower quartile, which is given by Q1, is 20. The lower quartile is 25% of the distribution, meaning 1/4 of the total. 1/4 of 30, which is 30 divided by 4, of course, 7.5. Where is 7.5 on our graph? 7.5, the rank. Here we are, 7.5, approximately here. So we draw a horizontal line, and from there we go down on the horizontal axis. So this is going to give the lower quartile Q1 as simply 10 centimeters. Right? Now what about the upper quartile? The upper quartile, denoted by Q3, is 75% of the distribution, meaning 3/4 of the total. This gives 22.5. We have to locate 22.5 on the CF axis. Here is 22.5, and from there again we draw a horizontal line, and we come down on the horizontal axis, right? This value will give us the upper quartile, which is 14.5 approximately, right? So this value is 14.5 Q3, right? Median is 12.5 and the lower quartile is 10. So I write it down, the upper quartile is 14.5 centimeters, right? Now to be able to find the interquartile range, meaning IQR, this stands for interquartile range, you take the upper quartile, you minus the lower quartile. In our case, the upper quartile is 14.5 minus lower quartile is 10. So this gives you simply 4.5 centimeters. Right? Sometimes you will be told to find percentile. Say for example, we need to find the 10th percentile. The 10th percentile comes from the word percent, meaning 10 over 100 of the total, which is 30. And this gives simply the third value, and on the CF axis the third value 1, 2, 3. So we are here. Again, we draw a horizontal line till we reach the curve, and from there we go down, and here the value is 9 centimeters. Box and whisker diagram is also known as a box plot. And what are the informations that define a box plot? They are the quartiles, the lowest value of the data, and the highest value of the data. Right? Below is an example of a box and whisker diagram. As you can see, the middle portion here is what we call the box, and the two lines on either side, we call them the whiskers. Right? So this is why it is called box and whisker. And the main advantage of a box and whisker diagram is that it shows the shape of the distribution, right? Whether it is symmetrical, whether it is skewed, and so on. We are going to discuss more about shape in the next session, right? Just keep in mind the advantage of a box plot is that it shows the shape of the distribution, and the main drawback, the main disadvantage is that it does not show frequency, right? This is a disadvantage of the box plot. Now, whenever we talk about shape of a distribution, shape of a distribution can be classified into three categories. Let us see. If you take a look at the first box here, that is this one, we observe that the distance from Q1 to Q2 is less compared to the distance to the right, that is from Q2 to Q3. So in this case, we say that this distribution is positively skewed. Right? Because the distance to the left is less than the distance to the right. What about the second box? For the second box, we observe that the distance from Q1 to Q2 is equal to the distance from Q2 to Q3, meaning these two distances, they are equal, or simply they are almost equal, right? So this is a case of a symmetrical distribution. And in the third box, we can observe that the distance from Q1 to Q2 is much greater than the distance from Q2 to Q3. Right? So this is a case of a negative distribution, meaning it is negatively skewed. Right? We are going to explain this in the next session. Right? But for the time being, just have a general idea of the shape of the distribution being positively skewed, symmetrical, and negatively skewed. Box and whisker diagram from a CF curve. Right, as we have said previously, a box and whisker uses the lowest value of the data, the highest value of the data, and the quartiles. Right, so here I have included the same CF curve from the previous example. Right, so we already have the curve. We start with the lower quartile. So the lower quartile is at 10. So we extrapolate the lower quartile, right? So this becomes the first boundary of the box at 10. Next thing that I will do is to extrapolate the median. Here it is. Next quartile comes the upper quartile. Right? So we already have the box. Right? Now we have to draw the two whiskers on either side. The lowest value of the data is here. It was 3. So we extrapolate this value of 3. Right? And always remember the whisker has to be in the middle. So this is the middle line. And here is the left whisker. Right? So this is the lowest value of the data. Now we have to draw the right whisker. The highest value of the data is this. We extrapolate it, we bring it down simply on the horizontal axis. It's on 21. We continue to go down and we have to draw the whisker in the middle up to this value. So here we are. So this is the highest value. Right? And the box, you have the lower quartile, the median, and the upper quartile. Right? Simply you extrapolate the values vertically down, then you complete your box and whisker diagram. Right? So this is the end of this second session.